So we will start the class for today. So today's topic and for the other days it will be Borneo schematics. Now I think I will be putting my screen for sharing. So that's my screen and we have the Borneo schematics already open. Now when you open it, you will find it in this way. Okay. So for that, you need to press this so that your files are uploaded here on the left hand side. And you should be able to see if you click any of the options over here, then the options will open up on the right side of the screen over here. Okay. So mobile phone solutions, you have mobile schematics and the solutions over here. System on chip means system on chipset, how the configuration or how's the overall uh the schematic or the circuit which is built inside the mobile phone, how that is designed. Okay, that part is over here. This also includes your CPU and the MMC, the power IC, the audio IC. All those sections will be explained on system on chip. Then you have is the data sheet. So data sheet is giving you the information about the IC. Let it be any type of IC. It could be your CPU, it could be your audio IC, it could be your charger, it could be your fingerprint sensor, it could be any other sensors, it could be duplexer, triplexer, EMI filters. All those things are listed over here. And then you have the fourth one, which is a diode array. This is a very useful piece of information over here, diode value, which is very good. Okay. Sometimes you extract maybe a power IC, but you don't know maybe if it is going to really work or not. So if you go in this section over here, you'll have to go in the power section. Once, sorry guys, once you get into the power section, you have a very common IC which is called MT6357CR. So once you click that, it pops up and it opens. So over here, what you see over here, the balls of the IC. This is the nose point at the back, and these are the balls, okay, of the IC. Now over here, if you will zoom in a little bit more further, you see all the balls, they will have the names and they have a GR. So this is giving you 0.789, 0.804, 0.429. So if you are able to check the GR of your IC in this format, okay, that means, and if you are getting the same GR, that means your IC is supposed to work. Now you have ground points over here. So basically, when you are checking the GR of your IC, you will point out your positive probe of your multimeter on the ground. And for example, you will point your black probe over here on audio handset phone. Okay. So you should be able to get this GR. So these points, what you see in the gray color, they are all ground line. Okay. I'm just checking one thing. Okay. Now, the most important over here is this one, this yellow color ones. These yellow color ones, basically they are the most important ones. If you get a GR on these points, that means IC is completely damaged. You should not be getting any GR on the yellow ones. See here, it is given 0.0L, means overload. Okay, means your specification of your multimeter is less. That's why you are getting overload. If you will increase the range of your multimeter, then you will not get overload. Okay. So try to take this GR in the diode mode, and in the diode mode, you should be getting infinity or OL. If you get OL, that means GR is satisfactory and the IC will be working. Okay. So this is one thing. Okay. About, I already explained about power. So there are different sections over here. You have audio. For the audio section, some of the audio ICs are listed. Charging section, some of the charging sections ICs are listed. Chipset means CPU. For the CPU also you have so many ICs already listed. Then in display you have graphic ICs which are displayed over here. These are all graphic ICs. Then you have internal storage, which is your eMMC or the UFS. Okay. All that eMMC or the UFS, there is a GR. Okay. Then on LCD light, for the LCD light section also, you have so many ICs, which is already listed over here. Then going forward, you have NFC. NFC stands for near field communication. Okay. So for NFC ICs also, the entire list is over here. For power amplifier, which is your 2 GPA and 4 GPA IC, that ICs will be listed here. And for power, which is your PMIC, those will be listed here. And on some of the phones where you have double decker, or maybe you have, three ICs, which looks almost the size of a CPU or a MMC or a UFS, then the third one IC will be your RAM. Okay. So this is for the RAM. Then you have RFIC. So RFIC, you know what is RFIC? RF stands for radio frequency. So this will have your RF ICs, okay, or WTR or SDR. Then you have your Wi-Fi. So this will have all your Wi-Fi IC listed over here. So now going on the top list over here, we will go with one particular brand. And let us go with which model should we go? Hasan Qadri.
I would suggest we go to Techno or Infinix.
Techno, which model?
Uh, I can't really say any model, because you can just give us. Maybe you should go through Hot 8.
Any specific model in Techno?
Hot 8 or Spark 4.
You can't see my screen. No, the screen is shared.
I said Hot 8 or Spark 4.
Spark 4. This
Yeah.
is Spark 4 KC2, Spark 4 KC8. Which one? Spark 4 Air KC1J is there. KC6 is there. Spark 4 Lite KC85 is there. Spark 5 is there. Spark 5 Air is there. Spark 5 4. Should we go with Spark 6 Air, KE6 or KE7?
The KE7.
KE7 is better, right?
Let's go with KC6.
Sorry?
KC6.
KE6. KD6.
K KCC for cup.
This one.
No.
This one.
Yeah. Yes.
This one.
Yes.
Okay. So we will go with this one. You agree?
Yes, sir.
Okay. So here you have so many options. What are these options now? First, let us see. In this one, you will have bitmap. In this one, you have a dioda. But in dioda, you have four sections which are common section. okay, which is connector. These connector ones, they are using different multimeters. Okay, Sanwa, Sunshine, Zotac, Fluke, all these multimeters, different multimeters they are using. So that's why this is having four sections, but they are all same. Okay, but the GR what they have taken of the connector, they will differ because of the make and the model number of the multimeter. If it is Fluke, you will get a different GR. If you take Sanwa, you will get a different GR. If you take Sunshine, you will get a different GR. And if you take Zotac, then you get a different GR. Now, what is IC on board? If you will open IC on board, when you remove any ICs, for example, in this section over here, we have one IC, which is this IC now. Okay. Now, what is this IC? This IC is supposed to be your power IC. Okay, because you have some of the coils which are can be seen. One, two coils over here, three coils, you can see it over here. So this is your power IC. So when you remove the power IC out from the board, if you want to check the tracks, they are okay or not. So to check each points where your IC balls are soldered on these pads, you should be able to get these kinds of values. Okay. In case if you are not getting these kinds of value, then you know what is the problem. Even if you install the IC, your phone will not work properly because the lines itself which is coming on the pad, that is missing. That is missing, or maybe the GR is incorrect. So you need to repair that particular line for in order to have the proper GR. Okay. So here you have this one which is IC on board. You understood? Okay, wherever there is an IC, you will see that they have given the GR of each and every IC. Okay, big ICs. Like this is 2 GPA IC. This is your 4 GPA IC. This is your WBR. This is your CPU. This is your eMMC. This is your power IC. And what else? Here also you have one Wi-Fi and Bluetooth IC. Here you have one more IC. Here you have maybe display or the light IC, maybe display IC, and what else? That's it. So if you have removed any of the IC, the very first thing what you will do is try to repair or try to check the what you call is the try to check the GR, okay. Your shop name is Future Mobiles or what, Hassan?
No.
Because
That's the second
someone from
person.
the group has messaged me, which is from Future Homes. Good afternoon, sir. Please, I'm having network problems at my end. Okay. So I'll just reply to him. Okay, I have replied him. No problem. Thank you. So here we have IC on board. So as I said, you can always remove the IC if any case, any section which is not working. If you have removed it, the very first thing, try to take the GR of the pad, see the GR of the pad is correct or not. Then you can similarly check the IC also, take the GR of the IC, and then you need to install it on the board. Just don't do it on a trial and error basis, because that will not make any sense and you will not be able to understand it properly. So unless until you don't do all these steps, it will become a little difficult. Okay. So what you need to do is try to pull out the before you, you have, if you have diagnosed the fault and you assume that the IC is faulty, for example, this IC is faulty, when you remove it, try to take the GR of the pad. And also when you try to, when you will be taking the GR of the pad, also do one more thing. Try to take the GR of the IC also to see if the IC will be in a working state or not. Sometimes, you know what happens is when we apply the heat, okay, sometimes maybe while checking the IC, you will get a proper GR. But when you apply the heat, okay, maybe the ICGR will change. And once it's changed, it becomes very difficult for you to figure it out whether that IC is going to work or not. So in this case, what we need to do is we need to be smart. Okay. So if you are going to remove any IC, first thing is before installing it in its place, just try to take the GR. See if the GR is okay or not. Maybe the line should not have any kind of short circuit on the GR. If any of these lines gets any kind of short circuit, that means the IC is gone defective. There's no point of putting all your effort and installing that IC. It's better to change the IC, get another one, take the GR, and then try to install it on the motherboard. Okay. So this is about IC on board. Then there is a very good section which is called in-out voltages. Now, what is in-out voltages is, I'll show it to you. This section in-out voltages is repeated. There is another section over here which is called voltages. So this is also giving you the same voltage over here, in-out voltage. Okay, in-out voltage. Both the files will be similar. So what happens is now in-out voltages, wherever your PM is there. For example, this is your PM. Now in the PM, when you try to power on your mobile phone, in the hot testing, so you will take your multimeter, take the negative probe and put it on the ground line. So negative will come over here. With the help of red probe, you should be able to get this particular VBAT. Okay. On this, you should be able to get this GR. Sorry, this is not the voltage line. This is your GR. This is this section over here, and this section over here is different. It is not the same. This is the GR, but in some cases they have given, instead of GR, they have shown only the value. Yeah. So now what happens over here, when you will take the positive lead and connect it on the ground surface of your motherboard, and with the help of black lead, you will take the GR, you should be able to get this GR. If you're not getting this GR, trace it in schematic from where it is coming. If it is coming from IC, straight away you know what is the fault. You will have to change the IC. So same way over here, vibration PMU, which stands for power management unit. See, this is VBAT line 0.283, 0.284. Okay, 283, 284. It will be very much similar. Wherever you will see VBAT, it will be same. I don't think anywhere else is there. Only VBAT is over here. Okay. Anywhere else you see VBAT? Apart from that, no. I don't see it. Okay. See, now you have a V bus which is 0.160. So on V bus, you should be able to get this particular GR. So in-out voltages, this section is giving you an idea about if the IC is connected, and if the IC is good, then at these points, and even the tracks are good. So on these points, you should be able to get these GR. And if you are getting these GRs, that means your IC will definitely boot and your power will switch on the motherboard. Your power IC will definitely switch on the motherboard. Okay. So this is about in-out volt value. IC on board, you understood. Connector, you all know what is connectors. So connector, I'm not teaching you. It's very straightforward. So going forward, we have here hardware solution. You have back camera. So in back camera, what you have? You have one connector which is here. Okay. And you have this side also. Same connector, this side and this side. Now, how they are being related? Okay. If you will see these lines, they are directly being connected to the camera connector on this side of the pin, which is right side. Now, if we will see this side where it is connected, let us see. If these are directly connected, see, there are pins, but these pins are through some components. If you will see, they are not directly being connected. They are being connected through some components. So in this case, if there is a fault for your back camera, which is 13 megapixels, and if it is not working, the very first thing, what you will do is, you will come here, dioda mode, take this, any of this, depending on your multimeter. If you have fluke multimeter, you can open the first option. If you have sunshine, you can open the third. If you have Sanwa, you can open the second. And if you have Zotac, you can open the fourth option. So your back camera is over here. This is your back camera. Okay, this side. This is the place where the back camera is sitting. So see, it's writing also back camera. So what you will do is, in order to repair the back camera, you will have to take the GR of each and every pin. If you get a GR, okay, as per what is being shown over here, that means the lines which is coming from the CPU to this side of the connector, they are perfectly all right. Okay, which means you don't have to put any effort on the CPU. Okay, so you will try to put all the safety measurements on the CPU and the eMMC, and then move further on this side of the motherboard, on this side of the connector. So over here, you have different GRs. If, for example, this particular GR, or wait a second. If, okay, if this GR is missing, the 45th one, I think you all can see the biggest, okay, number 15. If this GR is missing, this is your camera clock signal. So here you have a capacitor. Since this is not connected in series, check the GR over here. Then try to check the GR over here. For example, if you get the GR over here, but you're not getting it here, then you will have to put one jumper from this point to this point, and then you will take the GR. If you get the GR on camera clock on this point after putting the jumper, that means the line which was break over here to here, that line has been repaired, and that's why you were able to get the GR. Now, if you don't get the GR over this point, what you will do? You will further go and check from where this line is coming. So if you will keep checking, this comes from this particular component, and this is coming from here. So what you will do is, instead of putting the GR, or instead of taking the GR on the connector, you will try to take the GR on this component. And if you get the GR on this component, this will indicate you that the GR which is coming on this component on this side, the line or the ball which is connected over here on the CPU is perfectly all right. But if you're not getting the GR further over there, it could be that this resistor which is connected, which is of 0 ohms, you can see this value is given 0 ohms. This resistor has gone defective. This has gone open circuit. That's why you are not able to get the GR on this particular one. Okay. So what you will do is you will try to put one jumper from here to here and then try to take the GR on the connector and see if the line is become okay. Or if the line is become okay, it means your line has been repaired and the camera should work. Now over here, what we have in the back camera section, let us see some of the names of the lines over here. So you have RCP-B, RCN-B, RDP-B, RDN-B, RDP-1, RDN-1B, RDP-2, RDN-2, RDP-3, RDN-3, serial clock, serial data, camera clock, camera reset, and camera PDN1. So these are the lines, and most of the lines, they are already connected to the CPU. So here in this section over here, you don't have to do any kind of hot testing, or you can do the hot testing here. If you will see some of the lines which is coming from your PM over here, you have some of the voltages which will be coming. So this is VCAM input output PMU. So over here, you will have to check what is the amount of voltage you are getting or not. Over here also you will be getting some voltage. Okay. Then on this two lines also, you should be able to get the voltage. VCAM A PMU, VCAM D PMU. Okay, this is analog, this is digital. So this voltage will be in the form of analog, this will be a digital. Okay, so this is going where? One is going directly over here through this resistor, it is coming here. And the other one is coming like this through this capacitor over here. And then further diversion is changed and it is feeded over here on this point. Okay. So basically here also you have a 0 ohms resistor. So sometimes if this resistor is gone defective, then also you might have a problem with your camera. The camera might not work. Okay. So this is about the camera section, which is 13 megapixels. We will go to the next section, which is back camera QVGA. So you have back camera, which is over here from the CPU, and the connector is over here. So this is the main connector where your camera is getting connected. Okay. So now here we have some of the lines, which is also the power line. As you can see, this is the main power line, which is being connected. Let us zoom in. So this is the line which I am talking about. Okay, this is given here, and then further on, it is going on this capacitor also. And after that, it is not going anywhere. Okay, so basically that line comes, it gets filtered, and then it is being given over here. Okay, so that's the connection. Now here you have what you have. Camera clock, check this line, how it is coming. Same thing, 0 ohms, same resistor. Okay, if you will see on the connector, which is that connector. So this connector over here, you will try to take the GR on this connector. If any of the GR is missing or the GR is abnormal, you will have to repair the line. Okay. So here you can see this is no GR. There's no GR at all. Then you have serial data, PMU, all these lines, you should be able to get the GR properly. If your GR is okay, this back camera, which is QVGA, okay, that will also work. So it's not much very complicated over here. Okay, there's one voltage line and the rest of the things are being connected from the CPU. Okay, so it's not much of complications over here. Now there is one which is charging data. This must be very useful for you, because most of the technicians, they are getting stuck in repairing the charging section. They always complain that the charger they have connected, they have changed the battery, they have changed the subboard, they have changed the flex, but still their charging is not functioning, or they are not able to get their battery charged. So what are the lines over here? We have VBus, USB DP, USB DM. USB stands for Universal Serial Bus, DP stands for data positive, and DM stands for data minus. V battery means voltage from battery. Bat on means battery on. Auxiliary in 3 battery ID. So this is BAT ID means battery ID. This will be directly connecting to your connector. Okay, where your battery is being connected. On that connector, you will have the battery ID. Now let us see where is the main connector. So this is one line which is your battery ID, but I don't see that line over here, this color line. Do you guys see it? So there is some mistake from the Borneo side. I don't see that color. You have this one, which is your connector for the battery. Okay. But auxiliary in 3 battery ID, this particular line, which is in purple color or violet color, that cannot be seen over here. So maybe they have done some blunder over here. Okay. So let us not focus what they have not done over here. So we have your baton. This line is sensing the temperature and it is being connected over here. So this is on this particular line. So if you will see, zoom in a little bit more. It is coming on this orange color. Okay. Now if you go on IC on board, we will go to the same, which is the PM section. So the PM section is over here. We will zoom in. It is on the second row. And you have baton, which is 0.0L. So this is first, second, third, fourth. So do we have the fourth over here? First, second, third, fourth. Yeah, same line. So if this IC on the pad, when you have 0.0L, and if you are not getting any GR, what does it mean? It means maybe the IC which is being connected on this ball is gone defective. That's why you're not getting any GR. Now to check whether there is any GR on this ball or not, let us go and check that out. So this is your empty. Which IC is this? Anyone have any idea which IC is this? MT6357 CRB, right? Wait, we will check over here. You have the component name, or is it MRV? So this is 6357 MRV, okay, not CRV. So we will go to the data sheet, no, to the dioda value. Here you will go to the power section, MT6357 MRV. This is the IC. Okay. And you will have to search for the fourth one, which is your baton. So this is your fourth one, which is your baton. So here you have the nose point over here. Okay. Now why this IC is being shown in that way, I think you guys understand. So what you need to do is just take one particular point over here. Count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You have total 16. Okay. And here you have the nose point. So you will have to see where is 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. So this is your 16th one. So this, if you will turn it like this, your baton will definitely come on to this position over here. Fourth position over here. Somewhere here or here. Because you will twist your IC. You will twist it 90-degree anti-clockwise. Okay, because your nose point is over here. But when you're counting it from here, how many ball points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you will count it in series, that means 1, 2, 3, which is missing, 4, 5, which is missing, 6, 7, 8, which is missing, 7 and 8 is missing, 9, 10, 11, 12, 13, 14, 15, 16. So it is 16 by 16. Okay, it is in a square format. Okay, but your 16 points are on this side. But over here, what we see, 16 points, the nose point is over here. So the baton is over here. So now, if you will see the baton, you have a GR of 0.447. This is your GR. So when the IC gets connected on the board, okay, where you have the baton, where's the baton coming? Where's the baton? Here, which is infinity or too high value. Because your IC gets connected on this particular ball, you will get the same GR of this particular ball of the IC, which is 0.447. Okay. So now going forward, we are studying about the charging section. So how the charging section is working, we can see that definitely there has to be some voltage which has to come on this particular line, which is your VBAT. Okay, because on this particular line only your voltage will go, and in case if the battery has to be charged, the voltage will come. This is your baton, and maybe this one is your battery ID, or maybe this is ground line. This is not, this cannot be battery ID, this has to be a ground line. Okay, so how the voltage is coming to this point, that is more important. So you have your VBAT line, which is connected like this. It is connected to this one particular component over here, and then it is coming to this IC. Now this one is used for switching purpose. This is a transistor. This is also a transistor. This is also a transistor. How does it work? That you will have to see it in the schematic. So that one I will try to take it tomorrow in the schematic. Okay, because it's important for you guys to understand how is the schematic is done and how the switching takes place. Because see what happens over here, you have a VBAT line and you have your VBus line. Now if you will see, your VBus line is the line which is connected to this IC, and your VBAT line is also connected to this IC. So what is the connection between a VBus line and a VBAT line? Your VBus line will have a voltage of 5 volts, and your VBAT line will have a voltage of 3.7 volts. Okay, or maximum 3.8 volts, depending on the charge which is being stored on the battery. So what is the interconnection between this IC, why they have given VBus and why they have connected the VBAT? Okay. There is also diode which is being used. There's another set of transistor or an IC which is also connected. So what is this IC doing? That also we will try to understand. Maybe this is your V bus, because V bus is coming here, it 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 is all connected here on this IC. Okay. So we will try to study this. See, this is writing here charging LDO. Means this is charging LDO, low dropout, for charging which is given to this IC. Now, what is this ID? We'll have to see it in the diode value where you have pattern. Just leave 2, and this is see charging LDO 1. So this particular point they have used it, charging LDO. This is for sensing purpose. Okay. So basically we will try to explore here, but your main thing over here is your VPH is coming out from VCS line. Okay. VPH is coming out from the VCS line, and where you have the pattern. So you have the fourth lane, 1, 2, 3, 4, 5, and the sixth one. Okay. So if you will go here, you have fourth lane. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 1. See, VCS sense. So this is from here VCS sense, they are taking a VPH supply. So this is giving your VPH is being switched from this point, which is 0.385 GR. From this point, the VPH is being switched. To understand it more precisely, we will try to do it on the schematic, so you guys will be able to understand how the charging circuit works. And sometimes when your charging is not taking place, what are the immediate solutions for that? Okay, that thing we will try to learn it tomorrow. So for today, anybody has any questions related to any of these topics which we have already done? Any questions?
I have a question.
Yes.
What I really wanted to ask, what I really wanted to say is about the course layout that was given to us.
About the,
The course layout,
you mean the syllabus of the course?
yes.
Okay.
So I would like you to help us and check it and see if there's anything you haven't touched, you haven't make reference to. So during the basic class, so before we move to the advance of the course.
So this course is not good enough for you.
No, what I'm saying is like if there is any like there is course layout, so you can follow the process. So that there won't be anything left out.
You mean you want a entire syllabus of our institute, right? What are the topics which will be covered in the during
Yeah, that
time, right?
yeah.
This
Since
is
it's
what
from the layout,
from the,
from the course syllabus, so that you will follow it step by step.
okay, okay. So from the syllabus, you just need the syllabus. Okay, I will do one thing is I will put this question in my group, and whoever is being your support manager, they will try to answer or give you the course. Actually, if you will see what is the syllabus, here's the syllabus. I'll show you where is the syllabus. Maybe this is not updated. Sometimes it is difficult to update it. So you go here in the training section. you have all the course which is being highlighted for you. So if you scroll it down further, okay, this is maybe this is being changed now. But see here you have level 1, which is your basic. See, this is level 1 hardware and this is level 1 software. So how to use multimeter, how to work resistance, capacitor, diode, transistor, coil, LDO, etc. How to check all components, how to work parallel and series component. So this class I have already taken. What is the resistance, parallel, series? This is already done. How to use SMD and heat and air apply. How to down motherboard temperature. How to remove and fix plastic components. How to fix SIM tray, headphone and jack. How to find section. How to use universal stencil. And in the software, you have these courses. Okay. This is from the website only. You can get the complete. And here you have the advanced. Right now, you are doing the advanced course. Okay. And in the advanced course, in the hardware, here it is all the things which will be shown to you by another sir, whose name is Shehzad sir. Now the basic schematics. This is the syllabus which I am trying to cover.
Okay, so um, so from the previous one you showed me, so like how to identify the section, the component section, like the section of on motherboard, like which one is related to the network section, how to identify the display IC and the backlight IC on the section of the motherboard.
This will
So
be
I think
taught
maybe
over
you
here.
should make
Yeah,
emphasis
this,
on this.
yeah, this will be taught over here in the basic schematic. If you will see here,
All right.
for example, now I just opened one particular section over here. See, when you have this particular model, which is Spark 4 Add KC6, here they have described which IC is for what. Here they have written, marked it. This is PA3G. This is WTR. This is PA2G. This is your CPU chipset. This is your LCD light.
Okay.
Okay. This is your power IC. This is your
Hmm.
EMMC. This is your volume and power keys. Okay. These are two
Hmm.
connectors, back camera, front camera. Then you further go on the next page. This is your Wi-Fi, Bluetooth, and GPS IC. Okay. This is another IC they have written down. Maybe this is for graphics. Okay. This is your back camera. This is your battery connection. This is for your display, graphic IC. This is your another connector, which is for fingerprint. This is your LCD connector. So on this connector, you will install your folder or the LCD. This is your SIM card. This is your ear, and this is your SD card. Okay, Hassan.
Yeah. So what I wanted to say is there are some cases whereby you don't have the schematics of the phone. So how can we able to identify the sections?
Okay.
So just
That
by looking at the components,
that
like
also
you explained to
actually
us
I
on
yeah
the
yeah
power management.
I'm understanding now. Your point I understood. For example, if there is no schematic, there is no hardware solution, how to identify the sections on your motherboard if you don't have any hardware solution or you don't have any schematic. Now for the PM,
Yeah.
I think you should be able to tell me how you would identify that this is a power section because I have already taught that.
If you have bulk coils,
Yes. So
so like
wherever
two,
you will see a
five,
lot of buck coils, you will easily identify that this is a power management section. You know to identify a CPU and a EMMC, correct? right?
No.
You can identify,
I don't
right?
know how to identify.
CPU and MMC,
I
you can,
can't.
okay, here on this board, okay, the easiest way to identify the CPU and the MMC or the UFS is that they are the biggest IC on our motherboard. Both the ICs will be the biggest one. In size, you will say the biggest IC. So if there is another IC which is sitting next to the big IC, that will be your MMC or a UFS, and the IC which might be little smaller, that will be your CPU. See, in CPU, you have how many types of CPU you get?
Huh?
How many types of CPU you get? Which are the companies which are making CPU?
You have Qualcomm,
You have
MediaTek,
Qualcomm, you have
uh,
MediaTek, you have another one which is called what? Can you name it? Spectrum.
uh, Spectrum. Yeah, Spectrum.
Then you have another one which is called Kiran, Neeli Kiran.
No, I don't know that one.
Okay, that is also there. Then there's another one in Samsung which they are using is called Exynos,
Okay.
right? Exynos is also one CPU. So if you see on your motherboard, if you will see, identify that you have two big ICs. So definitely one will be your CPU. Either it will be MediaTek, it will be Qualcomm, it will be Spectrum, or it will be Elikiro. Okay. If you have
Okay.
a AMC, that could be having a name called SEC. That stands for Samsung. SK Hynix. Like for example, you have Kingston. Okay. Then you have SanDisk. All these ICs,
Okay.
Micron, MICRON, they are for MMC. Okay. SanDisk, Micron, Kingston, SK Hynix, Silicon. Okay. All these ones, they are called MMC. The CPU, they will have names on the written on them, either MediaTek, Qualcomm, Spectrum, or Elikira. Okay. In Huawei, you will find Spectrum and Helicron. Okay, they are the ones which are being used in Huawei type of mobile. And in Samsung phones, you will find Exynos, which is your CPU. Now, this you got to know. In the network section, when we will try to learn about the network section, that time I will explain that how you would identify which is 2G IC and which is 3G or the 4G IC, and how you will identify which is your WTR, SDR, or your RFIs. Okay, when we will learn. All these things will be taught to you in future classes. Okay. But if you want the course syllabus, they are all listed on our website. You can go through it and maybe make a note of it and see if the trainers, they are covering all the syllabus which is being displayed on the website. Okay.
All right. Sir. Okay.
All right then.
Thank you, sir.
Any further questions? What about Silvanus? You have any
Uh,
question? Okay.
yes, and there is one. There are some. You said there is a UFS IC.
Yeah.
Okay, that one too is big because in phones
No,
like
certainly, I'm okay.
Infinix Hot.
Okay. UFS, I will teach you little later because we still haven't covered that part yet. So I will let you know what is a UFS. Okay.
All
What
right,
is the
sir.
full form of MMC? That also I will try to teach you. What is the full form of UFS? That also I will try to teach you. And when you will get to know the full form of all these things, you will be easily, by the name itself, you will understand what is the role of a MMC or what is the role of a UFS. Okay.
All right.
In future classes, just keep on asking these questions so that it will become easier. Now, what we have discussed now, like how you want to identify which section is which, just keep on asking as I keep on covering one section by section. You can just ask me. Okay, now we are on the charging section, so maybe tomorrow I will let you know how to identify the charging section. Okay.
Uh,
All right, and
Thank you so much, sir.
thank you. Take care. Till then, goodbye. Good night. Take care and
Bye bye. Thank you so
bye
much,
bye.
sir.
Tomorrow will be off, so maybe day after tomorrow we will see you.
Saturday, right?
Saturday. Yes. Thank you.
All right, sir.